going to 2, it's not going to 2, it's going to 1.
Yeah.
As x goes to 2, you see this function from the left side. From the left side, you see that this function is going towards f of 2 equals 1, because basically we're plugging in 2 from this function, and we're trying to find where it's going towards on the y-axis, right?
Mm-hmm.
So as x goes to 2 from the left side, you see that y equals 1. As x goes to 2 from the right side, you see that y equals 1. So did I explain that a little bit? A little more sense. For this next one, as x goes to 1, you can see it's a little funky. I'm going to erase this notation I did. You can see it looks a little funky because we're trying to look at, as x goes to 1, we have an open circle right there and a closed circle right there. So we could just, visually tell that, the limit doesn't exist. But if you want to solve this, like show your work, you're going to have to do the one-sided limits, right? So for 1.3, we're going to do the limits as x goes to 1 from the left side of f of x, and the limits as x goes to 1 from the right side of f of x. So for this one right here, as it's going from the left, so we're going to follow the blue line from the left side of the graph. So if we go this way, where our green arrows go, this is where the function is going from the left side. And so we end up right here when we reach 1. So coming from the left side, the limit as x goes to 1 is going to equal 2. If we come from the right side of our function, we're going to follow the line, and we see that it's going to equal 1. And remember, if our one-sided functions don't match, then the limit as x goes to 1 in general does not exist. Yes, you should do the one-sided limits if you get something like that. Yeah, of course. So because the one-sided limits don't match, right, from the left, we got our left-sided limit is equal to 2 as x goes to 1. Our right-sided limit as x goes to 1 is equal to 1. Yes, Nyla?
Okay, so just for my own clarification, if any time there is the one-sided limits where one point on the graph is what is it, undefined, like if it's an open circle and a closed circle,
Yeah.
it does not exist regardless.
So just to clarify, your question was if there's an open circle, then it does not exist. I'm sorry, I missed the last bit of what you said.
Oh no, so you know how we're trying to solve for x going to 1? Mm-hmm. And there's 2 points. There's an open circle at 2 and there's a closed circle at 1. Well, that the answer does not exist since there's 2 points and one is open and one is closed.
That's not necessarily going to be the case, because if you remember in the first you see that we have a closed circle and an open circle right here.
Oh yeah. Okay. Thank you.
Yeah, no problem.
Yeah.
So yeah, you should show your work. I personally would show your work for this. I don't know if he give you I don't know if he'd take off all the points, but he might take off like a point or something if you didn't show the one-sided limits. Not that you have to show the one-sided limits every time, but for a graph like this, I think it's helpful, if that makes sense. f of 2 does not equal 2. And the reason why, as I explained earlier, if we follow the graph from both sides, f of 2 equals 2 is undefined. That's not correct. The function itself, you're right, f of 2 does equal 2 because there's that solid fold-in circle. But a limit is different from just evaluating a function. You want to see where the graph is going. You want to see where the function is going. Yeah. Even though the f of 2 equals 2, our function is physically going towards 1. It's physically going towards 1 right here. Because the function is physically going towards 1, that means our limit is going to be 1. Yeah, it's an open circle at 1, but that doesn't matter. It doesn't matter that it's undefined right there, or that there's a hole in the graph right there. The limit is still approaching it from both sides.